Good to meet you finally in person. Okay. So we're going to talk about rational functions here together today, and we're live on YouTube as well, so you guys can watch us later. But this is a nice
Hi, YouTube.
long session. I don't know how well they can hear you because I'm right here, but they probably can hear a little bit. All right, so let's create a new Jamboard. How about that? And let's minimize this thing so you guys can see it better if you guys want to look at my screen. Okay, so I'm just going to write down the questions that you guys have. You didn't put any of these on Jamboards, right?
No.
Okay, which one do you want to do first?
Number one. We'll
Okay, so x squared minus 25 all over 2x minus 2 divided by x squared plus 10x plus 25 all over x squared plus 4x minus 5. So here's the key with these things. You want to factor them first and then cancel what can be canceled. Actually, before I do that, I'm going to deal with this divided by. What do I do when I'm dividing something?
Cross multiply?
Mm-mm.
No? Okay.
You dividing by a fraction is the same as multiplying by the reciprocal. So you flip it, you turn it into, you turn this into times and then just flip it. X squared plus 4x minus 5 all over x squared plus 10x plus 25. Yep, just the second one. You only flip the second one. Think of it like this. If I said 5/4 divided by 1/3, think of it like this. Remember doing these problems?
Yeah.
You would, that's the same as 5/4 times 3/1. Think of it like this. 5/4 divided by 1/3. Well, dividing by 1/3, if I would flip this and do 3/1. So any one of those ways, you've done it before, but you're just not seeing, you're just probably not used to seeing this nasty of a problem to deal with.
Okay.
But we can do it still. So what are we gonna do first? Well, let's factor everything. So in the top, I'm gonna have x squared plus 25 is x plus 5 and x minus 5, right?
Yeah.
I don't have to explain that. You're good with that?
Yeah.
And what factors out of the bottom here?
The 2x minus 2.
Mm-hmm. You can see what factors out.
Mhm.
How about a 2?
Yeah.
And if I factor 2 out, what's left?
Just an x.
And what else? You have to hold the place of the minus 2.
Minus 2.
X minus 1,
Wait.
because the 2 came out of it. You're taking the 2. It's undistributing.
Oh, okay.
It's a GCF. That's GCF factoring.
Gotcha.
You understand that? Yeah. And the other
Do you
one,
have to do that or no?
you should always factor it as much as possible.
Okay.
Yes, you should. Okay, what's this other one do? What's this factor into? You know it's going to be x and x. And then what multiplies to -5 and adds to +4? Multiplies to -5, adds to +4. 5 and -1. And by the way, when you do this right here, you should have thought to yourself, oh, I bet there's going to be an x minus 1 up here somewhere.
Oh, and then you can.
Chances are there would be. Maybe not every time, but you know, a lot of times they are. And how about this one? What is this dot bottom factor into?
X plus 5.
Mm-hmm.
X plus 5.
Nope.
Oh wait, x plus 5 again.
Yeah. Okay. If you don't understand any of that, all you people watching on YouTube, then go watch some of my other videos about factoring. But you guys good with that?
Yeah.
Okay. So now we're going to cancel out common factors. Hey, those can cancel. Those could cancel. Hey, an x plus 5. So what's left on the top?
X minus 5.
Mm-hmm. Mm-hmm. And there's your answer.
That's it.
Mm-hmm. That's it. Now, if you want, I'm going to show you a little hack how to check your answer. Take a number and plug it into here. As long as it's not something that would make this whole thing 0, you can do it, like the denominator 0. So you can't plug in a -5 and you can't plug in a 1 because that just wouldn't work. But any other number will work. So how about 0?
So then x cannot equal 0 or -1 or 5, because we do that too.
Mhm.
Like on the back, we can
Yeah.
put X can't equal.
You should also probably write, along with this, you should write X cannot equal, because you canceled out a bunch of things. X cannot equal -1 and -5. You should write that, yeah. So let's just take, but I'm talking about a different hack. Let's take, it can't equal +5. Let's take 0 and plug it in here, because that's easy.
-5.
It's if I plug 0 in here, then I'm going to get -5/2, right? Now let's plug in 0 into this whole original one. Let's plug 0 into this up here. Oh my gosh. Let's plug 0 into this original. What are you going to get when you plug 0 in here? These are gone. You're going to get -25 over -2, right? Divided by, what are you going to get when you plug in 0 to all these x's? 25 over -5, right? So 25 over -5. Oh, what do I do when I divide? I flip it. So it's really going to be, this is going to be, and by the way, negative over negative is positive. This is going to be 5 over, sorry, times 5 over 25. Those 25s are going to cancel. Yeah, this is a negative, you're right. Those 25s are going to cancel, and I'm going to get what? -5 over.
So you could just do it all that way.
No, you're not just doing it. You're checking your answer.
Well, why can't you just do it?
Well, because they didn't ask us to plug in 0. The answer isn't, the answer to the question is X minus 5/2.
Oh,
But
I
I'm
forgot.
showing you how you can check to make sure you did it right. Like if you have time left over on your test, or if it was a multiple choice test, you could have just plugged in 0 to that and then to all your answers in your multiple choice and see which one equaled the same thing as what you started with.
Gotcha.
Okay. I didn't mean to confuse you there. I just was trying to show you how.
Yeah.
I'll leave that on there. How you can check your answer. Okay. All right. Next, which one next?
2.
All right, so we got x cubed minus 8 all over x squared minus 4. So that's a SOAP. Remember SOAP? Have you learned the SOAP trick yet? All right, so here's SOAP. These are just things that you should remember. If you have a squared minus b squared, that's going to factor into, watch this. It's going to be same sign, opposite sign, always positive sign. So the last is always going to be positive. It's going to be the same sign here, which is in this case is a negative because this sign's a negative. And this sign's going to be the opposite of that, which would be a positive. Okay. And then what you're going to do is you're going to take A and put it here. You're going to take B and put it here. You're going to take A squared here, B squared at the end, and A times B in the middle. And that's how that factors. It's just a kind of a formula you kind of have to memorize. So that also works for a positive one. If you had a plus here, this would be, what's the same sign going to be?
Plus.
What's the opposite sign going to be? And always positive at the end. And then it's again A, B, A squared, B squared, AB. That's the SOAP. That's the SOAP trick. Okay, makes sense?
Yeah.
So what's it going to be? So how is that going to help us?
It's gonna help us factor this out.
Yeah, it's going to help us factor this first one. So this first one is going to factor into x minus 2, because that's what's being cubed, right? 8 is 2 cubed, times x squared plus 2x plus 4. Okay. Got that first step? Oh my gosh, do I have the camera on? Hi guys. Let me turn off the video so that. Hi guys. You're like, hey, it's us. I didn't realize that was on this whole time. That's pretty funny.
Wait, why do you have like all those X's for no reason?
Yeah, wait, I'm a little confused. Can you explain that last? one more
Sure.
bit?
Well, remember what I did? Look what I'm using here.
Yeah,
I'm using this trick here.
I know, but there's only three.
but there's 3x.
Mm-mm-mm.
I'm
Look at it.
confused.
What's my A? What's my A?
And the x.
It's X. And what's my B?
Oh.
My B is 2. My A is X and my B is 2.
Right.
Because this, look, what is this? This is something squared minus something
You use
squared.
x 3 times in it.
This is X, I'm sorry, cubed. This is X cubed
Yeah, but
minus
X
2
is in
cubed.
there 4 times.
Well, that's because look how many times A's is in here. No, it's only in there 3 times. Look how many times A is in here. A squared, AB.
Wait,
What's my A and what's my B?
x is a and 8 is b.
2 is B.
2 is b. Wait,
Because what's being cubed? 8 is what?
8 is
8
being
is
cubed.
2. No, 2 is being cubed. 2 cubed is 8.
okay. Oh, okay.
2 cubed is 8.
Yeah.
Yeah,
Yeah,
but how did
yeah,
you
yeah,
get 2?
Because 8, look what 8 is a perfect cube.
Yeah.
8 is 2 cubed. 2 times 2 times 2 is 8.
That makes sense.
Why is 4 not cubed?
This one down here.
No, at the end.
I think she's asking why.
Because
4 is
look,
there.
look what I'm doing. Look at my formula over to the right.
Yeah, but it's b squared.
What's B?
b squared is 4.
What's B in this case? B is 2. So what's 2 squared?
4.
It's 4. What's A times B? It's 2 times X, which is 2X. What's A squared? Remember A is your X. So it's X squared. A is X, B is 2. Look, let me do it real quick and you'll see how that works. If I FOIL this out, what am I going to get? Watch this. That and that is going to be X cubed plus 2X squared plus 4X, right? That and that is negative 2X squared minus 4X minus 8. What happens to all these things in here? What happens to the 4 and the negative 4? 4X and negative 4X, they cancel. What happens to negative or 2X squared and negative 2X squared? You see the beauty of that? So what am I left with?
X third.
X cubed minus 8. And that's why that formula works. It just does.
Okay.
Would you have been able to figure that out on your own? Probably not. But if you memorize the formula and you recognize what you have, oh, look, this is a difference of perfect cubes. Differences of perfect cubes follow the SOAP factoring trick. Okay. So just remember that because you're going to see it. You're going to see it a lot. Okay. So let's go back down here. Let's work down at the bottom. So this is going to be X minus 2 times X squared plus 2X plus 4. And on the bottom, what's X squared minus 4? Factor into.
X minus 2.
And X.
Plus 2.
Good. See, you already know that strategy, right? You know that trick. Okay. And then what do I have left over here? X plus 2. And I have 3X. So what can cancel out?
X plus 2.
X minus, well, an X
Yeah,
minus
X
2 and the X plus 2. And
X.
am I done? I'm done. Nothing else is going to cancel out. So it's X squared plus 2X plus 4 all over 3X. That's your answer.
You wouldn't.
There's nothing else that can cancel out from that. So just leave it like that.
That makes sense.
Which
Good.
one you got right?
No, the next one.
That's a tricky one. All right. What's the next one?
This one.
Okay. So we've got, let me go black here. We've got 2X squared plus 5X minus 3 all over X plus 3 divided by 4X minus 2 over 2.
I don't even know what I did here to figure out.
So what do I do with division? What do I do with the division first of all? I flip it. So this is going to be 2 over 4X minus 2. Oops. And it's times now. And let's just go ahead and factor this out while we're at it. Notice this is a 2X up here. So this is going to be a little bit trickier. Not horrible, but what do I have to break it up into? A 2X and an X, right?
2X
And now I've got to find a way to make negative 3 multiply to these last numbers right here. This is my last. So it's either 3 and -1 or -3 and +1, and they could be in either direction. So you just have to kind of guess and check till you get it.
So it's 3 and 1.
It's got to be 3 and 1, but one of them has to be negative because of the negative sign here.
But it has to add to 5.
But it has to add to 5 when we do this.
And there's a 2 there, so we'll add.
And there's a
five.
2 there. So 2 times 3 is 6, right?
Yeah.
Minus 1 is
One.
5. So where should I put the positive and where should I put the negative?
-1 and then
Perfect. Put the -1 here and put the +3 here. That's called guessing and checking.
yeah.
And the bottom is just x plus 3. And of course, what can I do to this right here? The 4.
4
can I
and then
pull out of there?
X minus 1.
I can pull a 2 out, and it
You can
wouldn't
do
be
2x
x minus
into
1.
it. Yeah,
It would be 2x minus 1, right?
yeah.
So I'm just rewriting that. Okay.
I have a question.
Mhm.
Could you do like,
Well, we're not done yet, right? But do you want to ask the question now or after
I
we're
was
done?
just gonna say, can you do 2x minus 1 and 2x minus 1 instead of, is it the same thing?
That's not what it is, though. It's not 2x minus 1. It's 2x minus 1 plus 2x minus 1. But you don't want to do that. You want them to be factors because factors are going to cancel out. See how this factor and that factor now?
Yeah.
See this 2 and that 2? See that and that? All that's going to cancel out.
Okay.
Wait, so it's literally just 1.
Mhm.
Two and two.
The answer is just 1 because everything cancels. That's
Yeah.
gone, that's gone, and that's gone. So your answer is just 1. But remember, you have to say that x cannot equal -3. And it also can't equal, solve this for 0. That'd be 1/2, positive 1/2. Solve it. Write 2x minus 1 equals 0 and solve it.
Oh, you're right.
2x equals 1,
You're
x
right.
equals 1/2. Yeah.
So what's the answer?
The answer is 1, but x can't equal -3 or positive 1/2.
Yeah.
Does your teacher make you write that out?
Did you
Yeah.
write those?
Yep.
For
Did we do that for
everything?
this last one?
No, we didn't.
So what can x not equal here?
3.
It can't equal, no, it can't equal 0, which we don't even really have to write that because you can see it still can't equal 0.
Yeah.
But what did I cancel out here that I should mention? Look here,
-2.
and,
Two.
Positive 2.
So x cannot equal 2 or -2. Sorry, I forgot to write that. X cannot equal 2 or -2.
So X can't equal 1 or for the third.
1 or 1/2.
-3 or 1/2. I think.
Sorry, -3 or 1/2. Yeah, sorry.
Yeah.
-3 or
1 is
1/2.
not-
Wait, so why not 1?
1 is the answer.
Yeah, 1 is the answer.
This just simplifies to 1.
I did it differently, but I still got the same answer.
Okay,
For
good.
division, I literally just cross multiplied and I got 1.
I mean, that's essentially what you're doing, but they canceled out when you cross multiply it. All the things canceled out. That's
Yeah.
essentially what you're doing.
Okay.
You're cross multiplying because you're flipping this, so you're
Yeah,
multiplying.
but then I flipped this too. That was the thing.
That was, you kind of got lucky that it worked.
Yeah.
That's not the proper way to do it. The proper
Yeah.
way to do it is just to keep it as a like this, like I'm doing it here.
Okay.
Cross multiplying when you're doing a division kind of works. Just make sure that this goes on the top.
Okay.
Whatever you put here should go on the top, and whatever you put here would go on the bottom. Because look, that's essentially what you're doing. You're multiplying
Gotcha.
across. The reason it worked for this one is because everything canceled out
Cancels
anyway,
out, doesn't matter.
so it didn't
Okay.
really matter.
Makes sense.
Next one.
This one is 7/12 minus 4x over 3x.
7/12 minus 4x over 3x. Well, right away you can just say, hey, let's cancel those x's,
Yeah.
right? But you have to also say that x cannot equal 0. Remember that. At the end, whenever you cancel x's out, you should always just kind of write it off to the side. X cannot equal 0.
So whenever you cancel x's, it's always x cannot equal 0.
Anytime you cancel something with an x, you want to set that thing equal to 0 and solve it.
Okay.
You hear that? Anytime you cancel something, a factor that has an x in it, set that equal to 0 and solve it, and that's what x cannot equal.
Okay.
Because you just cancel it out. It's like a hole in the graph, basically. This last graph that we just did, That's basically just a line. This is basically, all this is a line, a horizontal line. So here's my XY axis. This is a horizontal line at 1, but the difference is there's a hole at -3 and there's a hole at 1/2. That's what this graph actually is if you were to graph it. If you were to say y equals this, it would be a line.
Okay.
You understand what I'm saying? Or if you were to graph it on a, yeah, I'm not, see, here's the thing. When you did this, there is no x. So you really, to say x cannot equal -3 or 1/2 doesn't really make sense unless we call this y equals.
Okay.
Are you sure it's right?
I know that in the back it says that we have to write it. But for these, I'm not for sure.
Was it on the
You see, the thing about this that you probably maybe you don't have to write it on these ones is because this is really just an expression. They're not asking you to graph this.
Okay.
They're just asking you to simplify the
These
expression.
ones, they
We
ask
don't
to
have
find
to-
the excluded values in the phone.
Right. But see, these
Oh.
don't even say y either. These ones here don't say y equals. So this also is just an expression.
Okay.
So again, I'm maybe giving you more than you need to know, but I think it's probably
Now
good
we're
to know
learning
that.
this, though, so-
Okay, so this one, I cancel the x's. And then I'm gonna go ahead and write, so this is just a good old this is multiplying or subtracting?
Subtract.
All right, so this isn't the same as the other one. This is like finding common denominators. So what denominator would be the least common denominator between 12 and 3?
3.
Nope, it's gotta be the bigger one, not the smaller one.
12.
Yeah, it's 12 because you need them to be the same. So how do I make the 3 into a 12?
You subtract the top or multiply the top by
No,
3
no, not just the top.
and the bottom.
By what? Not 3,
4.
by 4, because that's gonna give me 12 in the bottom.
Oh, okay.
Right? So the concept that I'm doing here is I'm actually just rewriting 4/3 so that it has a bigger denominator. The way I do that is I multiply the top and bottom. So it's kind of like the opposite of what I was doing with multiplication problems. Instead of canceling, instead of simplifying, I'm kind of complicating it. I'm complicating the problem, making it bigger so that I can add them together and then I can maybe simplify. So what I have is 7/12 minus 16/12. And now I can add them together. So it's 7
we
minus
add them?
16. Well, in this case, subtract.
Oh.
I can combine them because now they're like terms or they have the same denominator. And what's 7 minus 16?
-9.
And now can I simplify it even more?
Yeah, -3/4.
That's it.
And again, to say x can't equal 0 is a little bit, I'm not sure what your teacher would want you to say for that. Because technically, this is technically a different, this makes it seem like it's just a simple fraction. But in reality, the original expression, are you allowed to put 0 in here?
No.
You're not allowed to put 0. If you put anything else besides 0, you're going to get -3/4 as the answer, but you can't put 0 in here. That makes, you understand what I'm saying?
Yeah.
So I really do like to put x does not equal 0, even though there's no x here. You're basically saying don't use 0 as an independent variable
Okay.
or as an input value for that. I don't know.
Sounds good.
I don't know how to say it exactly. All right, what's next?
-2 over x plus 2 plus 4 over x squared plus 3x plus 2.
Okay, so when I simplify this, again, let's factor.
Would be x.
You know, one of them is going to be x plus 2,
And then x.
and the other one's going to be x plus 1. And hey, look at what I have here. I have an x plus 2 already here, a factor of x plus 2. So what do I have to do to get a common denominator between this and this?
Why do you think it?
Just like I did on the last one. What did I do here? because
Because
those weren't multiplying, or those were multiplying, not adding and subtracting. When you're adding and subtracting, the common denominator is this and this. I need both of these factors in the bottom. Just look back at this one. What did I need? I needed 12. I needed both of these factors, 3 and 4. So I had to take the smaller denominator and multiply it by what it was lacking, which is 4. So what is this one lacking?
X plus 2, X plus 1.
So what do I have to multiply by?
X plus 2, X plus 1.
Nope, I already have an X plus 2. What do I have to
X plus
multiply?
1.
Where at? Not just on the bottom,
On the top
also on the top. Do you understand what I'm doing? Does that make
Yeah.
sense? How I'm doing that?
Wait, can you say that again?
Yeah, I had to multiply this fraction was missing the X plus 1.
Yeah.
So I had to multiply it on the bottom and the top.
Okay.
And so now let's simplify that. Down here, it's going to be negative 2x minus 2. I distributed. Got it?
Yeah.
Plus 4. Did I have to add anything to this 4, or did I have to multiply it anything by that 4?
No.
I did not. Remember, you're multiplying that negative 2, not subtracting it. That's why you're distributing it. That's why I got
Yeah.
negative 2x and negative 2. And my denominator is just x plus 1 and x plus 2. Now what can I do?
Negative 2 plus 1. So
Mhm.
negative
Add
2
like terms.
plus 2.
Negative 2x plus 2 all over
You
x
put
plus 1, x plus 2.
You don't want to put it in the other one.
Well,
Okay.
now I have to be a little bit careful because maybe I can cancel something here. Let's
You can
factor the
cancel.
top to see if I can cancel.
Yeah.
Remember, I have to factor it first.
You can cancel the 2.
Not yet. Let's factor out a negative 2. Okay. See what it looks like when I take a negative 2 out. It's going to be x minus 2, right? When I factor a negative 2 out.
Mhm.
And can I cancel x minus 2 and x plus 2? Can I cancel those?
No.
Are these two the same thing? Not at all. So I'm actually done. I
You
can't
want it in
simplify
that
it.
full, like, factored form?
I would always put it in that factor form. You could multiply it out if you wanted to.
What about the 4? Oh wait,
We
you
already
did like
did
terms.
that.
I'm stupid.
Yeah, I just add them together.
Gotcha. This one looks like the,
Now, in this case, I don't have to write x can equal 1, -1 and -2 because you can see that it can't. I don't have to put that in there unless they ask me what
Really?
is the domain. If they ask me what the domain is, I would say all numbers except -1 and -2. But I don't actually have to write that in here for this because I didn't cancel anything out.
Okay.
You understand what I'm saying?
yeah.
All right, this one's
Which one?
6.
Okay, so this is a good one. Now we've got what's called a compound fraction. So we got 1 over x plus 1 over 2x plus 1 all over 4x over 2x plus 1. Okay. So there's a couple different ways you can do this problem. You can deal with the tops first, just like we did that other problem, getting common denominators. And then you can flip and multiply this if you wanted to. Or you can flip this and multiply at the very beginning and just distribute it in and then deal with each one of them separately and then deal with adding your final sum. Or, and this is what I like, you can do what's called multiplying by the least common denominator. Multiply the top and the bottom by the least common denominator of all the fractions.
It's too much work.
It's
Yeah,
not. This is much better. I'll show you why. I don't know if your teacher taught you this, but this is a much easier way to do it. If I multiply the top and the bottom by x and 2x plus 1,
Yeah.
you're going to see why. So what am I doing? I'm multiplying the top and the bottom by the least common denominator of the entire fraction. Do you see why that's x and 2x plus 1?
No.
There's a 2x plus 1. There's an x. Here's another 2x plus 1. I don't need two of these because they're the same thing. So my least common denominator is just 2x plus 1 and x. So I'm multiplying by x and by 2x plus 1.
Wait, so what about the 4x?
You're going to see. I'm doing the denominator, just the denominator. Is this in the denominator?
Yes.
No. Is this the denominator?
Oh, that's in
No,
the
that's a
numerator.
numerator. Okay. Now, why am I doing this? Because now when I multiply this
Oh,
in,
I
watch
see
what
you're
happens. When I multiply this in, what's going to happen here? Let me color code these so you can see what I'm doing here. When I multiply these in like that, and then I'm going to multiply this into here, and then I'm going to multiply this into here. Okay. The red one, what's going to happen with the red?
They can cancel out.
The x's are going to cancel, right? And what am I going to have? When the x's cancel, when I multiply this into here,
Oh,
because
you're
that's in
gonna
the
have 1 over
top,
4.
now 1/4, all I'm going to have is,
Wait,
here,
why?
let me write this out
Yeah.
because you guys are going to be confused if I don't. I can just tell. So I'm going to write 1/x. I'm going to leave lots of space here. 2x plus 1. And then on the bottom, I have 4x, 2x plus 1. So I'm multiplying x times 2x plus 1 into all of these. And where is it multiplying in? At the top or the bottom?
The top.
Yeah, it's always multiplying on the top. X and 2x plus 1. What's going to happen right here? What's going to cancel?
X's here.
The x's are gone.
All of them.
Those x's are gone. And
So
what's
just the
left?
2 plus 1.
2x plus 1 is left. Got it?
And then the other one wouldn't.
Mhm. What's going to cancel
the
for this?
2x plus 1.
Yep, the
The
2x plus 1 is going to cancel. And what am I going to be left with?
X,
Plus x.
which is 3x plus 1.
Yeah, let's do that later. And what's going to cancel on the bottom here? What's
Wait,
going to cancel down there?
The 2x plus 1
plus
would just be 4x.
Mhm. Not 4x. What's 4x times x? There's still an x there.
4x squared.
Mhm. You get that?
Oh yeah, I just forgot that.
Mhm. You see how much easier that was?
Mm.
Eh?
Yeah, that was-
Really? Eh? You want to do it the other way? It'll take you.
So it's
Oh,
2x
it'll be a lot of writing if you do it the other way.
It's just like
plus 1
confusing.
plus x.
Yeah, what's
over
2x
4.
plus x?
3x
So it's 3x plus 1 over 4x squared. Done. That is so much easier than the other way of doing it. So much easier.
Yeah, that was actually easier. Not that I know the other way, but
Now, you do have to say something right here, though. What did you get rid of originally? What did you get rid of? What do you not have anymore that you originally did have, and you have to put that as a restriction?
2x plus 1.
You had a 2x plus 1 and you had an x, which are no longer in here. Well, the x is still in here, right? 4x squared includes an x. So you don't actually have to say that x can equal 0 because you can tell x can equal 0 still. But you should say that x can equal -1/2.
Okay.
So you should write x cannot equal -1/2. And the reason is because if you set this equal to 0, if you plugged in a -1/2 originally, what would you have had? You would have had 1/0, and you can't do that. Okay.
Yeah.
Honestly, if I did this the other way, it would take I would fill this entire piece of screen up. And I'd have to write really small because there's you'd have to do all kinds of like common denominators and flipping and multiplying and everything. You'd still get the same answer, but it's a lot harder. So just remember that it's called clearing fractions is really what that's called. I call it clearing fractions.
Okay.
You didn't clear all of them, but you cleared the majority of them.
Okay.
So let's see, do we have another one like that? Let's see if we can find
There's
another one.
not.
None of
We
them?
have
You have
these
no more
shorts.
compound?
No, it's just like one example of each, I think. on this worksheet.
Okay, so we should maybe practice some more of that. So here we go.
These ones are
Directions,
like
find the
two.
excluded values. Okay, so find the excluded values for this. Well, if we simplify this, we're gonna get, let's factor out an x squared. And we would get x squared plus 1. So excluded values mean what are you not allowed to plug in? So let's set each one of the denominators equal to 0 and see what we get. If I set this equal to 0, what do I get?
0.
I should say each one of the factors in the denominator. Yeah, you'd get 0. So x cannot equal 0, right? Because if it did, you'd have a number over 0 and you can't have that. How about this one? Is there anything I can plug in here that would make
-1.
this whole thing 0?
-1.
Well, if you put -1 in for x, what's -1 squared?
1.
It's +1. So would that really cause a problem? It wouldn't cause a problem. So really the only excluded value is 0. And again, let me show you how you could do it another way. X squared plus 1 equals 0. Just solve that equation. X squared equals -1. This x equals the square root. Wait a minute, I can't take the square root of -1. So you're like, I don't have to worry about that. That's an imaginary number.
Okay.
Okay, so the excluded value is only 0. This one too, find the
Yeah.
excluded. So let's do the same thing for this. Let's find the excluded values of the following. That's the direction. X cubed minus 2x squared minus 3x. So let's factor this. Let's take an x out first, and you'd have x squared minus 2x minus 3. And now let's try to factor that some more. X times, what is that going to factor into?
X times x minus 3.
And x
Plus
plus 1. So what are my excluded values?
3 and -1.
Good. So I'm setting each one of these things equal to 0 and solving. So x can equal 0, x can equal 3, and x can equal -1.
Is
So you
it always 0?
You set them equal to 0 and solve. Set the factors in the
I know, but
denominator.
that's like, it's like the easy part. It's probably just like,
You gotta take an x out. That's what we didn't do. You
yeah,
always have to take a
it's
number out.
just like.
You don't, I mean, you
Factor.
don't have to, but it's much easier if you always want to factor the GCF out before you factor anything else. It's just easier to factor.
Okay.
Okay.
These ones I like kind of get. They're like,
Okay, so now we have another kind. This is solving equations. So I'm going to teach you another trick with solving rational equations.
Oh, I have a couple in here too that are like the ones that.
Oh, good. So x minus 6 over 3x. Okay, so to solve an equation, kind of depends on what the equation says, but what I would recommend that you do, remember what I told you on the other one, clearing fractions? If you can multiply the entire both sides of the equation by the least common denominator, usually that will make your problem a lot easier. Not always.
This is the one that we don't like.
So this one is just what's the least common denominator of the, it's just 3x. So if I multiply everything by 3x, watch how beautiful this is.
yeah.
When I distribute it into this first one, I get 3x. When I put it into this next one, what am I going to get? 3x is cancel, right? So I'm just going to get x squared minus 5x minus 24. That make sense?
Wait, why don't you multiply the top by 3x?
I-
Oh, it's just the denominators.
I am multiplying it on the top, but they're canceling out. It's canceling. This 3x is canceling with this 3x, and this 3x is canceling when I multiply it into here. The 3x is canceling with that
so it'll
3x.
just be the
So it only,
numerators.
well, and that's right.
Okay.
It's going into the numerator because it's 3x is like
Wait,
3x
I
over
thought
1.
You have to multiply the numerator. So
I
why
do,
didn't you
but
do the x minus 6?
because what happened right here, when I went to multiply the 3x in, what happened? What happened when I multiplied it into here?
Well, you still have to like.
No, the
Good.
3x's cancel. Here, let me show you the work. Let me show you the work better.
Oh no, I know.
Do you understand what I'm talking about? So I'm taking 1
Do you, Izzy?
and I'm taking
Yeah.
x squared minus 5x minus 24 over 3x, and I'm taking x minus 6 over 3x, and I'm multiplying the 3x into each of these
Okay,
on
I
the
get it.
top. These
but-
cancel.
Yeah, so it would just be.
So
equal
it's
to
just 3x plus x squared minus 5x minus 24 is still there, equals x minus 6. And now
You just solve.
I just solved the equation by moving everything over to the left side, to one side of the equation, right? So that's going to be x squared. Let's see, this is negative 2x, but when I subtract another one, it's going to be negative 3x. Got how I did that?
Yeah.
This is negative 24, but when I add the 6, because it's got to move over,
30.
it's going to, nope, add the 6.
Yeah, negative 18.
Negative 18 equals 0. No, I'm not done, because now I have to solve this equation. So let's try to factor it. How do I factor? Put an x, put an x. What's negative 18? What multiplies the negative 18 and adds to 3? How about 6 and 3?
6 and 3.
Negative 6 and positive 3?
Yeah.
So x equals 6 or x equals
Negative.
negative 3. Now you always want to check your original and see what the excluded values were. Are either of these values excluded?
3.
No, the only
No,
one
they're
that's
not.
excluded is 0, right? You can't put a 0 in for x. So these are not excluded. So they're good.
Okay.
So if you plug these into the original equation, negative 3 for all the x's, guess what you get? Left side equals right side. If you plug this in for all the x's, guess what you get? Left side equals right side.
Wait, there's 2 answers?
Mhm.
There's
Two
never
answers.
been 2 answers.
There's always 2 answers.
For
X is gonna have-
quadratics, usually there's 2 answers.
Okay, here's the next one. I'm trying to
Wait, I
start
don't
on
get
it.
how you did like you got this like wouldn't you just add the 24 to the side
How'd I get this right here?
instead of putting all like
I'm just moving everything to the left side. So I'm just subtracting x and adding 6
why?
because I want to set it equal to 0. Because that's how you solve quadratics. You set them equal to 0 and then you factor.
No, because all of these I've just been getting one answer and they're right.
Well, that's when you have linear equations. When you have linear equations, you get one answer.
No,
But
these are rational.
Well, rational equations can turn into linear or they can turn into quadratic, but this one is a quadratic. See how I have a quadratic here? Sometimes you don't have more than one answer. Sometimes you just have one, but sometimes you have 2, sometimes you have 3, sometimes you have 4. It depends on the problem. Okay,
Mhm.
good.
Mhm.
So this next one, let's see if you guys can tell me what to do. This is similar to that other one. So I've got 2 over x minus 3. Is that what it says?
Mhm.
Plus 1 over x equals x minus 1 over x minus 3. What's the trick I taught you?
Multiply.
Multiply everything by what?
X minus 3.
And
X.
x.
So
X
x
and
minus
x
three.
minus 3. Right? And remember, where are you multiplying that? In the
Numerator.
numerator, which means you cancel, right? You cancel the denominators. So what is the 2 ultimately going to be multiplying?
2x.
It's just going to be x. Very good. What's this 1 right here going to be multiplying?
X minus 3.
So it's just x minus 3. And what's this x minus 1 ultimately just going to be
Yeah,
multiplying?
2x minus 1.
It's just going to be multiplying x because this is going to cancel.
Oh yeah.
So but use parentheses. It's x minus 3 times x. So there's my equation. What kind of equation is that? Is it a linear equation or quadratic? Can you tell? Can you tell if it's linear? It's not linear.
Quadratic.
Yeah. Why is it quadratic?
I don't know.
Because what are you eventually going to have when you multiply those things out? Are you going to have an x or an x squared term?
X squared.
Yeah, you're going to have x squared term.
Oh, okay, I get that.
So you're going to have x squared minus x and then 3x minus 3. So where should I move everything, right or left?
Right.
Yeah, move it to the right because you want to keep this positive. So let's subtract 3x. So x squared minus 4x, and let's add 3. Does this factor?
Yeah.
X minus 3 and x minus 1. So what does x equal?
1 and
3 and
3.
3 and 1. Uh-oh. Uh-oh. Why am I saying uh-oh?
Because it can't equal 1,
Because it can't equal
3.
3.
Wait, why?
Because look at the original.
Oh, okay. Okay, I get it now. I get it.
Izzy, was I allowed to say that x can equal 3?
No.
No, because 3 would give you 0 in the denominator.
Yeah. Okay.
So what do I have to do?
X equals
I have to
1.
cross out 3, and that's called a what?
No.
Extraneous. That's called an extraneous solution. Well, your teacher maybe hasn't taught you, but that's what it's called. So your real answer is only x equals 1.
Yeah.
Good?
Yeah.
Next.
I have these practice ones. Can we do another one of these ones?
Yeah, these are fun. Which one do you want to do?
We do this one.
So here we go. Ready? X squared minus 2x minus 8
Yeah.
all over x
Yes, literally had it
squared
right.
minus 16.
30.
It was like
You
4.
should just be like, I'm so sorry. With COVID, it's so hard to keep these masks up. So,
Like, I'm so sorry. I literally picked it
okay. So you ready for this? Now this one is a simplification one. So what I'm going to do, what am I doing? I'm dividing a fraction by another fraction. So what do I do with the bottom one?
Last one. Multiply it.
I multiply it by the
GD.
reciprocal.
Oh,
No,
just
I
kidding.
multiply by the reciprocal. This is not an adding and subtracting. This is like the other ones. This is a fraction divided by another fraction.
Wait, is this the one? No, this is not the one where you said.
You guys understand what I'm saying?
Yes.
This is the one that we did like this.
So for this one, you're just gonna
Oh yeah.
nope, it's not like this. It's not like this one is more like one of the first ones that we did. Let me show you what I'm talking about. This one is not like this one. It's not like this one because this one has a plus in it in the top. We don't have terms in the top.
Oh, okay.
You understand? This one is more like the original first one that we did. This is like this one. This is this divided by this. It's just written differently.
Oh.
It was as if they wrote this, like if they wrote this with this on top and this on the bottom.
Oh, so we just literally switched.
flip it. Yep.
Yeah.
Do you understand what I'm saying?
Yeah.
Izzy, do you understand what I'm saying?
Yeah. But
This
Yeah.
is not where you have to clear fractions. This
Oh,
is where you
so
just
literally
rewrite
switch
it and you
order.
factor and you divide and you
So it's like
cancel.
this,
No,
but this for-
Because it's like this instead.
it's a division problem,
Yeah, that's what I'm saying. Like
but
this.
it's not a clearing fraction one. It's
Isn't
just
this
a
a SOAP
simplifying.
one?
There is a SOAP in this, yes. So here, I'm going to rewrite this. So you guys can see what I'm talking about. Times, see what I'm doing? And then flip it. Flip the bottom one, because dividing by a fraction is the same as multiplying by the reciprocal. Okay.
Yeah.
And now we're going to factor and cancel. And you mind if I just do it right here? Can I just write it above it? What does that factor into?
Which one?
The top.
The top. X minus 4.
Minus 4
X
plus 2. Good job.
Yeah.
What's this bottom one factor into? Izzy, you tell me.
X
X and X.
minus 4.
X minus
X
4.
plus 4.
Perfect. And how about this bottom one over here? This is easy.
X minus 20 and X minus, or X minus 20 and X plus 1.
Nope.
Well, X.
It's going to have to be 5 and 4, right?
Yeah.
Which one's positive and which
Oh,
one's negative?
It's negative 1. X minus 5 and X plus 4.
Perfect. Okay, now this top one's tricky, but let's go. I'm just going to do it. You ready? It's SOAP. What's being cubed here?
With X.
And what's being cubed here? 125 is, do you remember what 125 is? Here, I'm gonna write the perfect cubes. Ready? 1, 2, 3, 4, 5. What's
It's
1
5.
cubed? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Remember those numbers.
Yeah.
Okay?
Okay.
Remember the perfect cubes, at least the first
Remembering
5.
perfect cubes.
At least the first 5,
Okay.
right?
Yeah.
So it's going to be x and x squared. It's going to be 5 and 5 squared. And then it's going to be 5 times x. Now, what are the signs going to be?
Same.
Same,
Opposite.
opposite,
Positive.
always positive. So,
Yeah.
okay, good.
Yep.
You ready to start canceling?
Yeah.
The x minus 4 and the x minus 4 cancel.
Yeah, wait, one second.
The x minus 5 and the x minus 5 cancel. Now, sometimes you can see this and there'll be even more factoring you can do. Sometimes when you do some factoring, not in this case, but every now and then you get some crazy stuff like that happens.
So you have x plus 2.
So what
X
do I
plus
essentially
4.
I have? I have x plus 2 on the top, and I have x squared plus 5x plus 25 on the top. And on the bottom, I have x plus 4, and I'm going to write it like this, x plus 4 squared,
Oh, okay.
just because you can.
Got it.
Now, what can x not equal? What did I cancel out? That's not there anymore. Look at the things that cancel out.
-4.
Not -4,
4.
+4, or
Wait, no, I thought the second
Positive
one just
5.
had x plus 4, not x plus 4 squared.
We'll look at what's in the bottom here.
There's 2 of them, Izzy.
Oh,
There's 2 left over. Good.
Yeah.
Shall we do more?
Yes.
Wait, where do I-
Once you get the hang of this, I hate to say it's easy, but it's kind of easy. It's not easy, but you guys are doing well. The key is you need to learn how to factor. You have to know how to factor. Oh, this one's different. Let's try this one. This is easier, but it's tricky for people. So this is a different kind of problem. Here's what it says: 6r squared s cubed over t to the 5th. Nope, t to the 3rd times 3s squared t squared all over 12 rst. Is this easier for you or harder for you?
Harder.
Should be easier.
Oh, wait, they all
It's the
cancel.
same thing. Just look at what cancels. But let's break it down more. What's 6? 2 and 3, right? What's 12? Let's just break them all down to their primes. 2 and 3 and 2, right? 3 and 4. 2 and 2 and 3, right?
Yeah.
So let's just do the numbers first. What is left over, or what can I cancel? One of the 2s is going to cancel. One of the 3s is going to cancel. So what am I left with number wise on the top?
An O or an S.
Number wise
2.
on the top.
On top. No.
On the top, I still have a 3. You see that?
Okay.
The 3 didn't cancel. So I'm going to write the 3. And how about on the bottom? What number am I left with?
2.
2. Okay. Now let's deal with what letter do you want to deal with first? Doesn't matter.
R.
R. How many R's do I have on the top?
2.
And how many do I have on the bottom?
1.
So how many do I have left when I cancel?
1.
That's right. Because one of them cancels out and I have 1 left on the top. Got it?
Yeah.
How about S's? How many S's do I have on the top?
3.
Look carefully.
Or 5.
I've got 5 total on the top, right? Do you see that?
Yeah.
And how many do I have on the bottom?
1.
1. So how many cancel?
4. 1.
1 cancels and I have what left? 4 on the top. Got it?
Yeah.
How about the T's? How many do I have on the top?
2.
And how many do I have on the bottom?
4.
So how many cancel?
2.
And how many are left?
2.
On the
Bottom.
done.
Hmm.
Okay. Do you see how it's similar to what we did?
Yeah.
You're just canceling factors, but you have to make sure you factor. See what I did at the beginning? I factored those numbers so that you could clearly see what cancels.
Can you do it?
More. What else? Mhm. So here's another one of these problems. Identifying the kind of problem it is pretty important. Yeah, go for it. Identifying the kind of problem it is an important skill. Okay. So here's what we have. Is that right? So first of all, factor.
Yeah.
This one factors into R. I bet you it's R minus 2, and then it must be R minus 5. How did I guess it was R minus 2? Because there was an R minus 2 already here. So I figured that it probably is going to have an R minus 2 in it.
Okay.
And so I knew the other one has to be R
So-
minus 5. And sure enough, yeah, that worked.
So it would be R minus 2.
And R minus 5. So that I'm rewriting this. See how I'm rewriting that?
Yeah, but like what would be your least?
Good. That's what you're going to do here. You're going to multiply everything by R minus 2 and R minus 5 on the top. R minus 2, R minus 5. And when I multiply that here to this one on the left, what's going to happen? What's going to cancel out?
The R minus 2.
And what's going to be
R
left?
minus 5.
Good. When I multiply it here, what's going to cancel out?
Both of
And what's going to be left? Don't say nothing.
1.
1. And when I multiply it here, what's going to cancel out?
R minus 2.
And what's going to be left? 6
6
times.
R minus 5.
See how easy that was?
Yeah.
Clearing the fraction is definitely the way you want to go with these problems.
And then
Just now, is this a linear equation or a quadratic?
quadratic.
Look carefully. Am I ever going to have an R squared here?
No.
No, I'm just going to have a 6R minus 30. And on the other side, I'm going to have an R minus 4. So this is not quadratic. Quadratic means you have an R squared or a variable squared. I don't have a variable squared.
Okay.
So just move the R's to the right. So that's 5R. Move the other numbers to the left. So add 30. That's 26. So R equals 26 over 5.
Okay. Because like I get like
And then of course, check to make sure that it works. 26 over 5.
so I get like these ones. Like these ones are easy.
Let me show you how you can check in your calculator.
No, calculators.
But I'm just showing you how you can check in your calculator if
know
that's
how
right. Do you? You know the store button?
Yeah.
You're good with the store button?
Maybe we use our calculators like all year.
I know, they don't let us.
So you would store this number for X, let's say 26 over 5, store that for X, and then literally just type this left side into your calculator very carefully with the X's and hit enter and see what number it gives you. And then type this into it, hit enter, and those numbers should be the same. That number and that number would be the same if you did it right. There's other ways to do it too. You could plug this into your calculator for one of your y equals, and then plug this in for your other y equals, and then see where they intersect. And it's going to be at that value. Both good tricks to know.
Okay.
Next.
Um, this one. No, that's easy. That's easy.
Wow, it's easy now? Those are easy for you now?
Ooh,
How about
let's
this
do
one?
this one.
This looks tricky.
Can we do these two? 11 and 13.
Sure. So 1 over x minus 1 plus x plus 3. Did I write that right?
Yeah.
All over x minus 3 plus 1 over x plus 4. Okay. So notice that this has terms on the tops and the bottom, right? Because there's pluses and minuses separating things. It's not just one big fraction on the top and one big fraction on the bottom. That means the strategy for this one, most likely, is to multiply the top and bottom by the least common denominator, which is that and that. Those are my two fractions. Those are my two denominators in the numerator and denominator. Get what I'm saying?
Yep.
that, and that. So I'm going to multiply this by x minus 1 and x plus 4 on the top and on the bottom. Okay, now follow me. When I do that, when I multiply this into here, what cancels out? This into this first term, what cancels
X
out?
minus
Yeah, x minus 1 cancels out, and all I have left is 1 times x plus 4. So that's just that.
Wait. 1 times x plus 4.
Because
Oh,
this
okay,
x plus
okay,
4 is here.
Yeah.
Okay, when I multiply it into here, when I multiply this thing into here, what happens?
X plus 4.
I get x
cancels.
times that. No, nothing's going to, right here, nothing's going to cancel.
Oh,
So this
no.
whole thing has to get multiplied by this. So it's x times x minus 1 times x plus 4. Same thing with this. When I multiply this to here, what happens?
Nothing.
The 3, right? Nothing cancels. So I have to just keep the 3, and I'm going to have to multiply those out.
That's a lot.
It is
Is
a
there an
lot.
easier way?
So there might be an easier way for this one. There might possibly be an easier way, but this is probably still the easier way to do it. There might be an easier way though. I'm not sure. This is why I said earlier, sometimes there's an easier, sometimes this isn't the best strategy. It just kind of depends on the problem. But let's do this now. Let's multiply this into here. Same deal, right? X times x, oops. X times x minus 1 times x plus 4, yes?
Yeah.
And then same deal here, 3, negative 3 times x minus 1 times x plus 4. And what cancels with this one?
X plus 4.
So I just get x minus 1. Okay. So I know this is kind of a pain, but it's gonna clean up. And I think it'll be, I hope it'll be okay. It might not be. We might have made it more complicated because it's going to be a cubic potentially. I'm just hoping things cancel out. Yeah. So how do we do this? Well, we go distribute. Let's just go ahead and multiply this thing together to see how we've got it in a lot of places. Let's just multiply that together so we know what it is. It's going to be x squared plus 3x minus 4. That's what that's going to be. Okay, so that's what all of these things are. So let's just go ahead and simplify this. It's going to be x plus 4 plus, now notice what I'm doing. I'm multiplying x squared plus 3x minus 4. I'm multiplying that by these numbers in front, right? X squared plus 3x minus 4. And this is x squared plus 3x minus 4. The more I do this, the more I think that there would have maybe it would have been better to do it the old-fashioned way, which is to just get the least common denominator. I'm sorry, which is just to multiply this by x minus 1 and this by x minus 1, and multiply this by x plus 4 and this by x plus 4 on the top and bottom. It probably would have been easier, but it's still probably it's gonna definitely give me the same answer. Let's see which one. Let's see what we get here. So this one's going to be x cubed plus 3x minus 4. Sorry, 3x squared minus 4x. Got it. Plus 3x squared. I'm just distributing that in, plus 9x minus 12. Got it. All over x cubed plus 3x squared minus 4x minus 3x squared, distributing that in, minus 9x. Is that a plus 4 there? No, that's a minus 4. So that's plus 12. Negative 3 times negative 4 is positive 12, plus x minus 1. Now let's just simplify these. So I've got an x cubed on the top. I've got an x squared, or 3x squared, and another 3x squared. So that's 6x squared. I've got an x and a negative 4x. So that's negative 3x, and a 9x. So that's positive 6x. And then I have a 4 and a negative 12. Anything else? So that's what, 8, negative 8?
Yeah.
So that's my top. In the bottom, I've got another x cubed here. I've got, oh, those cancel.
Oh, wait, yeah.
That's nice. So I have no x squareds. I've got negative 13x. Oh, no, plus another x.
Plus, yeah. So negative 12, or wait, negative 14x. No, negative 12x.
Yeah, negative 12x. I was looking back to see if I made a mistake. Negative 12x, I don't think I did yet. Wait, no, is that right? Negative 13 plus 1, yeah, negative 12x. And then I have 12 and a minus 1, so plus 11.
Yes.
And that's your answer.
That was a lot.
It's a lot. Now, the other way you could have done that, tell me which one you think is easier. I'll do it the other way just really quickly, okay? Whoops, did I just make a copy of that page? I meant to. Duplicate slide. Okay, tell me if you like this way better. Okay, so there might have been an easier way. Sometimes clearing the fractions, that trick I taught you, sometimes that's not the best trick because it's simple enough. Like, see how this doesn't look too complicated just to deal with this in the top and the bottom. So what you could do is you could just take x minus 1 and multiply it in the top and the bottom of each of these. Here, let me give myself some room. You could write it like this. Izzy, watch this. You have an x minus 1 plus x, leave some space, plus 3. And you can put the x minus 1 and the x minus 1, x minus 1, x minus 1 all over. In the denominator, I have x, I'm going to leave some space, minus 3, I'm going to leave some space, plus 1 over x plus 4. It needs an x plus 4 in the denominator, right? So I'm going to put an x plus 4 and an x plus 4. I'm going to put an x plus 4 and an x plus 4 because those all need that denominator. You get what I'm saying?
Yeah.
So then I would get, my next line would be, so the denominators, all of the denominators up here are x minus 1. So I just add the numerators together. So in the top, I have x minus 1 in the denominator, and I have 1 plus x squared minus x plus 3x minus 3. See what I did there? I did it quick, but I multiplied those things out. And now I have a common denominator of x minus 1. So I'm adding those in the top. There's the 1. There's the x squared plus 2x. And there's the 3x minus 3.
Okay.
And do the same thing in the denominator. The denominator is going to have an x plus 4 in it.
Yep.
And this first thing is going to be an x squared plus 4x. This next one's going to be minus 3x minus 12. And this last thing is just going to be a plus 1. Okay, so let's simplify this now.
This is so long.
All right, this is no matter how you do it, it's going to be a long problem. X squared plus 2x minus 2 all over x minus 1 all over. I'm just adding these like terms up here. So that's an x squared. That's a plus x, and that's minus 11. Sound familiar?
Yeah.
And this is an x plus 4. And now how do I deal with these things? Now I have that kind of problem I had at the beginning. How do I divide a fraction by another fraction? Multiply by the reciprocal. So this flips to the top and flips upside down. So let me do that in red. This is just times x plus 4 all over x squared plus x minus 11. And guess what you're going to get when you FOIL these things out?
What's down there?
Yeah, you're going to get what's down on the bottom. You're going to get a cubic on the top, and you're going to get a cubic on the bottom. And nothing really cancels. So here's the advantage to doing it this way, is if you can see how it's kind of in factored form right now. And if something cancels, you could see it right here.
Yeah.
Sometimes when you get to this point, you can't see, oh, wait, I should factor something out because something else is going to cancel.
Yeah. I kind of like this way better.
This one is hard no matter which way you do it.
Yeah.
This one's tedious. There's lots of little steps. So let me just make sure this actually works out. So when I multiply it out, it's going to be x cubed plus 2x squared minus 2x
Like this hard.
plus 4x squared
Yeah, I don't think this hard
plus
is gonna be on the test.
8x, I doubt it, minus 8, that's my numerator. And the denominator is going to be x cubed plus x squared minus 11x
Let's do like
minus
20.
x squared minus x plus 11. So you're going to get an x squared, you're going to get x cubed 6x squared, which checks out, plus 6x minus 8, yep, that's the same thing. And then the bottom, yep, those cancel out, yep, it's the same thing. So that just means we did it right both ways.
Okay.
One more?
Yeah.
Which one?
Let's do this one. Let's simplify. How do we simplify following rational?
Just factor.
Use
Factor and cancel.
Oh, okay. Then let's do.
That's an easy one.
No,
Okay.
choose to do one like
This is a trickier one because you're going to have to do it twice.
really want to be
Either one.
maybe.
This is a good one to look at. Look, real quick to show you how that one factors.
Okay.
This is going to factor into x squared plus 9 and x squared minus 9. But then you can do more with which one?
X squared plus 1.
Not both of them, just one of them. Which one can you factor more? Is this sum of perfect squares or a difference of perfect squares able to be factored?
Perfect. No.
Difference of perfect squares. Do you remember how x squared minus 9 is x plus 3 and x minus 3?
Oh yeah.
But this one isn't. That one doesn't factor. This one factors. X plus 3 and x minus 3. So that might be on the test. Just be aware of that. Where you think you're done factoring it, oh, there's more I can do. Just be aware of that.
Wait, why can you only factor one of them and not the other one?
Well, because x squared plus 9 just doesn't factor. Try to solve it. What do you get when you try to solve it? X squared equals negative 9. Can you take the square root of a negative number? No, but for this one, if you solve it, x squared equals positive 9. Oh,
You can take the square
plus or
root.
minus 3. There's my plus or minus 3 right there.
Okay, that makes sense.
Okay.
Yeah.
You want to do a different one now that you were looking at?
No, actually,
I just wanted to point that out because I saw that right on one of your sheets. I saw that as a
Okay.
part of the problem.
Can we do a soap one again?
Sure. Right there. Soap. X cubed minus 64. Which number was that? So I'll do the whole problem. It's x squared minus 5x plus 6 all over x squared minus 2x minus 3 times x squared minus 1 all over x cubed minus 64. So how does this one factor? This first one up here? What does that factor into? What's that top one factor into? Teresa, you know it.
X plus 3 and x minus 2.
It wouldn't be x plus and plus because remember,
X minus. X plus 3 and x minus 2.
no, both of them are minus. They either both have to be negative or both positive because that's a
Wait,
positive
it's a
thing.
positive. Shoot, sorry.
So how about minus 3 and minus 2?
Minus 2.
And this one here, Izzy, how does this factor? X and X.
X plus
One of them's got to be a negative, one of them's got to be a positive.
X plus 3. X minus 1.
Close. It's going to be X plus 1 and X minus 3 because this is a negative 2. Get it?
Yeah.
How about this top one over here?
X minus.
See how it's a difference of perfect squares?
Yeah.
Difference of perfect squares, not a sum.
X
It wouldn't
minus
work
one,
if it was a
X
plus. right? It wouldn't work if that was a plus in here. If this was a positive, that wouldn't work
Why?
because of what I just told
Oh,
you,
because wait, so sorry.
right?
Yeah.
It's not a it's not a sum of perfect squares. Now, this one would work if it was a sum. A sum of perfect cubes does work. Okay. You understand what I'm saying? Okay. I don't know. So what we're gonna do here, we're gonna do SOAP. Ready? What's being squared here? Or
64.
cubed? What's being cubed?
64. 4.
4 is being cubed. So what am I gonna write? I'm gonna write x and 4, x squared and 16, and 4x. You understand where I come up with those numbers?
Remind me of how you came up with 16.
So what's being cubed?
4 times 4.
Mm-hmm. 4. So it's going to be your x is here, your 4 is here, your x squared is here, your 4 squared is here, and your 4 times x is in the middle.
Okay.
Now, same, opposite, always positive. Same, opposite, opposite, always positive. Got it?
Yeah.
And now let's just cancel. What can be canceled?
X
Minus 3, plus 1. Now you might want to check, is there more I can factor here? And
Yeah.
there actually isn't,
Why?
because it's a negative, it's a positive here. So 16, what multiplies the 16 adds the 4? Nothing. So you're just done. You're done. Your answer is just x minus 2 and x minus 1 on the top. And on the bottom, it's x minus 4 and it's x cubed. Actually, what we could just write, you could just write this back again, because you know it doesn't simplify, none of that canceled. So you could just write this and it looks a little bit nicer.
Okay.
And you say x does not equal -1 and +3. Okay,
Makes sense.
good.
Yeah.
All right. That's hard. That's some hard work.